Hello, everybody, and thank you for attending this webinar. My name is Inigo Serrano, and I'm responsible for business development at Bequant. And today we're going to present you our network optimization solution. During the session, we want to show you how our product can help improving your internet service and the quality of experience that you provide to your users. The webinar will last around 30 minutes and will be presented by Jose Lopez, our CEO. After Jose's presentation, there will be a Q&A session. Please leave your questions on the question tab of this webinar application. We will try to answer them at the end of the session. The webinar will be recorded and will be posted on Bequant's YouTube channel, so you can review it afterwards or share it. So Jose, please go ahead with the presentation. We're ready.
Okay, thank you, Inigo. Good morning to all, and thanks also to all the participants. Let's try to show you how our network optimization product works and what it does. So what does our product do? It helps you optimize your network in 4 ways. The first one is with TCP optimization. We are able to increase the speed that your users experience. Then we can also analyze what is going through your network so that you can make decisions based on that analysis. That analysis includes some aspects of security because we can detect denial of service attacks. And then we can also do bandwidth management, which allows you to limit the speed of certain applications or the speed of subscribers to enforce their rate plans. So in a way, we can, while for instance, all networks have times when they are not congested and sometimes where they may be congested. When there are no congestion, with our TCP optimization, we will make your network faster. And when there is congestion, with our bandwidth management, we will manage that congestion, lower that congestion, and enable you to offer the best quality of service that can be provided under congestion. So let's go with first trying to show you where our equipment goes. Our product is a software product that runs on a hardware, off-the-shelf hardware. In certain markets, we provide you the whole appliance already installed and ready to go. In some other markets, we allow you to just get your own server. We will guide you in selecting the hardware, and then we send you the software, which is very easy to install and get ready, and we help you in doing that. And when we have this server ready, it's an appliance that sits in your network somewhere between your internet gateway and the access gateway. Where exactly depends on your network, your routing, how many customers you have, if you have different sites. We also help you see which is the best location for that in your network. So once deployed, then let's go with all the 4 things that the 4 main areas in which we can help you. The first one is TCP Acceleration. Here, what we do is to increase the speed experienced by your users. And the speed experienced by them is not the same as the speed that your network may provide, because what they experience is the speed at which applications use your network. If they are, let's say an example, if you have, for instance, a subscriber may have a 10 megabit per second connection, but the subscriber may be using Netflix, for instance, and if Netflix sends at 5 megabits per second, then 5 megabits per second is what he's experiencing out of your network. So in many cases, applications are not able to use all the capacity that your network has. And what we can do is to allow those applications to use the capacity to to the optimum, to the limit, more, do not leave unused capacity. In this way, your with the same network, your subscribers, your users will be getting experiencing a faster network, and a significantly faster network in many cases. So, of course, the question then is, why would an application like, in our example, Netflix, stand at 5 megabits per second when there are 10 megabits per second available? And the answer lies in transport protocols. Transport protocols like TCP or UDP, they have been there from the beginning of internet. They are great, and they do many things. Among them, from the server point of view, the servers decide at what speed to send at each time. And this is a difficult decision, because if they send too fast, they will overwhelm, congest the network, and drop packets. If they send too at lower speed than what is possible, then they leave capacity unused. So, but what happens is that TCP and most and basically all transport protocols, they are conservative. They try, in order not to clog the internet, they tend to send at a lower speed in many cases than is what is actually available. In a perfect network, they will select the optimal, the perfect speed. But when a network is, when there are large delays, when there's wireless in the way, and there always is some wireless with Wi-Fi today, when there are packet losses, in those situations, TCP and all transport protocols, at some point, this tend to decide that the optimum speed to send is one that is actually lower than what the network is possible, what the network allows. So it is in these situations when there is TCP that we can help. And TCP is around, today still around 80% of internet traffic. So in many situations, we can help getting applications to run faster. And what we do in order to do this is not magic. What we do is something called transparent TCP proxy. This is something that has been done in networks for a very long time, for over 20 years more. For instance, in satellite networks, you need a device like this to handle the very large delays that satellite links have. Without that, they would not basically work. So this is also something that's in use in many of the large wireless networks in the world, like AT&T, the US, Vodafone in many places and around the world. There are larger networks. So it is something that is used in the that has been used for a long time in many large wireless networks to optimize them. But we have now made this functionality available to smaller networks, because that what those large networks use is usually a very expensive equipment to do this. So how does it work? Well, let's see with this short animation what happens. Let's imagine that you have two servers here on the right. This is just an example. They want to send 7 packets to some clients on the left. Okay, so we'll have they'll send TCP will usually do this like in 3 rounds, like first 1, then 2, then 4. They trying to probe the network capacity of each link. So on the top, the clients, when they get these packets right, they send these acknowledgement packets saying that everything's all right. And basically, we'll have on the top this path without any TCP acceleration. On the bottom, we'll place one of our appliances somewhere. This is a 5-second link just to see the packets flowing, and 2 and 3 somewhere in between. Okay, so when the server starts sending the packets, we'll see what happens with our node. When the first round of packets arrives at our node, we will send an acknowledgement packet saying that we got this first round right. Okay, and let the packet go on. When this acknowledgement reaches the server, in our case, then it sends the second round. So this second round of packets, these 2 extra packets, are ready so that when the actual acknowledgement from the real client arrives, then we already have that second round ready, and we can send it out. And so in this, for instance, in this case, we've gained 4 seconds over the path on top. And the same will happen each time with each round, except the first one. So in this case, we've gained out of the second and third round 8 seconds. So if this took 17 seconds, then on top it'll take 25 seconds. So the key here is about this buffering that we have, that we are building in between, where so that basically when this client is sending the acknowledgement packets, it's seeing that the next round comes earlier. So for it, the internet, the server just looks like it moved to inside your network, because this VQN server would be inside your network. So the contents are now closer, and when closer means faster in internet. So in a way, we are similar to a cache server being placed for all internet inside your network. We're not the same as a cache server, because we don't know what is flowing inside, so we cannot store it for other connections. Each connection has its own buffer, because basically we are storing there things that are mostly encrypted, in fact, so nobody really can go into the contents, and we can't, and we don't need to, in fact. So we just keep this buffer here, so that for this for the end users, the contents we basically manage to be ahead in each download by a couple of rounds, not more, because we don't want to store everything up front. We just want to be a couple of rounds, a few packets ahead in the download. And normally, on this side, the network is faster, so we can do that. And then basically, now we can dispatch them faster when they are required by the end customer. But of course, this if, for instance, if there are any packet losses between us and the end user, this is great, because TCP and all the protocols, these transfer protocols, when there are packet losses, with this acknowledgement packets, basically these that are sent by the client, we get information about which packets are missing, and we just retransmit them. But in this case, we are retransmitting them from much closer, so they don't have to go to some server somewhere in the internet and get the missing packet. So when there are packet losses, this will actually accelerate the downloads even more. And finally, so far, these advantages all come from basically getting the contents closer to your end users. And also, but there's also another advantage that we can get, even when in many cases, the servers are sitting right next to us. So the fact that we actually get the contents on our server doesn't change the delay so much, because we are maybe a few microseconds away from those servers. So in that case, coming from us or directly from the server would not be, there's no latency difference. But however, when we do send out the packets, we're using our TCP protocol, which is basically the standard TCP protocol, but we've changed. So we have some patented algorithms that can basically do the calculation how fast to send in a much more optimal way, and not be fooled like standard TCP, because also we know that we are already in the access network, and basically we can make a much better decision. And in many cases, we will get much closer to the optimal speed at which to send compared to TCP, which will, or it could be other, but we're focusing here on TCP, we will send faster than standard TCP. And how do we see this? Well, for instance, with this graph, which has a lot of data, let me explain, when we deploy our system, we always measure connections with our connections, how fast they are going, by checking the acknowledgements at what speed they're coming. So we're checking actually the speed experienced by the user. And we check that for normal connections, accelerated, but we always leave around 1% of connections without any acceleration, any optimization, so that those just go through us without us doing anything, except that we do measure them. And so in this way, we can measure and compare the speed of optimized and non-optimized connections. And in this case, we are showing the data, just concentrating on, we are showing here 12 networks. We have our node in over 200 networks, there are 300 nodes around the world. this is 12 of them, very different networks, from wireless ISPs to cable to fiber, everything, all kinds. And basically here we're comparing the speed, the average speed of Netflix downloads in those networks with optimization versus without optimization. With optimization, the speed in megabits is here in red, and in gray without optimization. And this is the average for a whole week of those Netflix downloads. We select Netflix not because Netflix has anything in particular. It's just that it's a large an application that's used everywhere, and it uses TCP like most others. So, for instance, if we concentrate on this network, this fourth, the wireless ISP, we see that the average speed that we were sending those Netflix downloads was 2.55 megabits per second, whereas the connections that did not have the optimization were going at an average of 1 megabit per second. So this network obviously was able to send at 2.5 because we were sending at 2.5 average. Okay, this is just average. But on average, Netflix tended to send at 1.04. So the same network now with optimization feels much faster than without optimization. So this is the key in these cases, when actually this was happening at times of congestion and at times when there was no congestion. So that means that in these networks, in most networks, this part of the speed that is where the bottleneck is TCP, the transport protocol, it would not have helped, because if the network was not in congestion, it would not have the extra capacity that it did have was not helping. So basically getting a more gigabits per second connection to internet would not give you a faster connection to those customers. So here it's what this bottleneck is TCP. It's just with this TCP proxy that you can get this extra speed from your network. So this is a TCP optimization, and this is what you'll get: a faster network. And now let's go with the second main thing, because in many cases, well, you're not so worried about this faster network when you get to congestion, because in congestion, basically, there's a limit. You cannot go any further than, for instance, what your down link from your central office to certain subscribers, or maybe the congestion can be on the link from the internet to your network, whatever. But at some points, you may reach some congestion. So in those cases, how we can help you is to reducing the bandwidth of your network, how much traffic needs to be pushed. And one way that helps a lot is being able to manage limit the speed of certain applications. In particular, video streaming. Video streaming is the largest traffic by volume in almost all networks, and by far. And it has an advantage that the advantage that if you limit it a little, the speed of video streaming, the video streaming applications will just adapt to that, because they use adaptive bit rate in all cases. And so they will adapt to that by having maybe a little less resolution, or a little less quality, but many times something that's not barely noticeable, but the traffic can go down by a lot. For instance, if you have a connection doing 4K video, that's around 25 megabits per second. If you reduce that to full HD, that's around 4 or 5 megabits per second, so 5 times less. And well, the difference in quality is not really 5 times less. It's not that. And in fact, in most devices, in small devices, it's barely noticeable. Only, I guess, kids can see that. But at the same time, you're reducing by 5. It's not a little. So so if you can limit the speed of these video streaming, and if you can do that only when it is necessary, because you probably don't want to do that when there is enough capacity in your network, and we allow you to do that. For instance, you can select which users will get for instance, 4 megabits per second limit or 8 megabits per second, you can decide, for instance, that they may get a certain limit. All the video streaming for a subscriber may be limited to 4 megabits or 8 megabits or no, or have no limit. For certain subscribers in a different way. When it's video streaming, or maybe when there's other, you can also do this for software updates, different things that we are able to differentiate with our DPI. And you can also select to do this when the network, for instance, is running above a certain, for instance, if you have a 3 gigabit per second network, maybe when the network reaches 2.9 gigabits per second, then you apply these limits, and not in other situations where maybe you don't need to do any reduction in speed. So, for instance, when we have done this in networks, we have seen how this is the traffic in a network when we did this. Basically, here you have different days, and there's a typical pattern where you have at night and during the day. This network reached close to 850 megabits per second. The blue one is the total traffic in that network. The others is the typical different kinds of traffic, TCP, DPI in that network. But in any case, when we enforced these limits in this case, it was, I think it was a 4 or 6 megabit per second limit on video during those during the peak traffic periods. Basically, the peak traffic on that network was reduced by 18%. That's what we see in many networks. If you apply these kind of limits, you reduce from 15 to 20, depending on how aggressive you want. But in all these cases, this was done without any complaints from subscribers. So, in fact, in many cases, actually, by doing this, the quality is better because you know, if you don't do this, there is a limitation. You have to live. The fact is that there is congestion. Okay, so the alternative is whether to reduce a little and then get everything with a much better quality overall, or let congestion arrive. And when congestion arrives, then everything is degraded. So in fact, letting them go faster is a recipe for getting everybody a much worse situation. So this is a tool that is very valuable. We're not doing this to you know, get low quality. You get actually much better quality. And then a different way in which we can help you with bandwidth management is just by enforcing the rate limits of subscribers. So we can have you know, you can have your plans with 8 megabits, 4 megabits, 25, 100, whatever, however many megabits, and you can configure this in our application by saying which network, which for instance, IP addresses have which limit, which subscribers get which limit, or which by IP address ranges, or you can get that information about who gets what limit via radius. We can get the radius accounting packages from your PPP OE server or some other node, and from there learn what is the rate plan for each subscriber, and then have a different rate for each rate plan. Or you can also program that through to us through our REST API, through which you can select again, decide again which users get which plan. And what is the advantage of our doing this with us? Because you can do that with MikroTik or for instance, PPPoEs or with Presim, and other applications can do this rate, or your OLTs can apply these rate limits. So what's the advantage of doing it with us? Well, we have a technology, that a very advanced technology, where we are able to do 1 queue per flow. So basically what we achieve is, in congestion, basically have reduce the latency for interactive flows, because in congestion, that's the key. I mean, when there is congestion, there is a limit. Okay, and congestion in this case is when subscriber reaches it's the limit. For instance, if it's a 10 megabit per second plan and three people are watching Netflix in that home, they will reach that 10 megabit per second limit. So there will be some congestion there. So the key, the best that you can do in that situation is if you don't do anything, but if you just limit to 10 megabits per second, okay, Netflix will be very smart and will get 3.3 megabits per second for each one, more or less, and they'll be quite all right. Now, the problem will be if they try to do some browsing or if they try to do some online gaming at the same time, because Netflix will also be pushing all that stuff in a very effective way. So basically, it'll build huge latencies normally, or packet losses if the buffers are not large enough. So the key is to okay, let the big ones, the big heavy traffic go through, yes, but during those situations, let the interactive ones not suffer the latencies caused by the large flows. And that's what we managed to do. For instance, in this case, imagine this guy, this user has 3 services running, and when a packet, the internet in this case this is a packet that came from this user from the right, which is the internet, and we have to send it to the left. Of course, it has to wait here in a queue. This is a YouTube packet in this case. Now this diagram, and it has to wait in a queue because, of course, it's coming faster from internet than this guy has reached the limit. So it has to wait in a queue. The key thing is that, well, okay, as more packets come, we store them in that queue, and they have to wait. Okay. And there's no way around that. All of these systems for limiting need queues. Otherwise, you would just throw away those packets, and that would be very bad. And now here comes another. These users also using Netflix. So another packet, it gets another queue. Okay, as it gets its own queue, and now that's one of the difference. You are getting a queue for each application, for each flow, for each TCP connection, UDP connection, or whatever protocol connection. Okay, and this queue, okay, will keep these queues will grow as the packets come. Okay, of course, at some point, there's a time when we can send to the user. Okay. Like here, for instance, now finally it's getting a packet. And the way that we do that is that we send packet for each of the outstanding, the queues, which have any packets to send. Now, the key here is that if you have here an interactive application like an online gaming or Skype, any voice over IP, any teleconferencing thing, those normally use very little bandwidth, but they do require these low latencies. And so this packet from Skype will get its own queue. It will not wait on the queue, the YouTube queues or the Netflix queue, which can be huge. And now the thing is that this came now, if there was just one queue here, it would have to wait for 20 packets to go through. So it would have basically a large delay. But in this case, no, because now it's turn. I mean, the worst case would have been to wait twice to queues. Okay, and so we've accomplished with this what we wanted. Basically, since you have each flow gets its own queue, each flow does not have to wait for others. So if it is light flow, like a connection like online gaming or voice over IP, it will just wait for itself, which is basically will not wait. However, there can be flows like Netflix, YouTube, all the video streaming ones, which will have huge queues, maybe, but which are not a problem at all for in fact, they work great with huge queues. Netflix and all those, they build large buffers, and that's how they work well, because in this way they will not get any video stalling and things like that. So we are achieving this with this multi-queue technology, the best of all worlds. We think, of course, I mean, the fact is that there is a congestion. You have 10 megabits per second, and that's all. Okay, so we have to manage those 10 megabits in the best way, and we believe that this is the best way possible. How do you test this? First, if you do try just saturate it with more number of YouTubes and Netflix in parallel, and just try to do some web browsing, and you'll see the difference. Now, we also get an extra advantage because this is integrated with TCP acceleration that I already explained. So that basically, in fact, we are for connections that are very, they may have very bad, link, for instance, Wi-Fi connection coming from a basement in home. For that one, we are helping with our TCP acceleration, because as long as it is below the limit, I mean, we're just helping with TCP. It's always there. Okay, it's just that if a connection is at 2 megabits per second and the limit is 4, we'll help that one get closer to 4. If it is already at 3.9, we will not help it go to at 6, because it will be limited to 4. Okay, and also because in those TCP packets, the acknowledgements, that we're sending all the time to the server, we are also telling the server exactly how many packets it can send to us. So basically, when there is TCP, we will not have any packet losses. We will be able to do this enforcement of speed. And just, in fact, we're enforcing the speed limit at the source. We are forcing YouTube to go just at the speed we want, okay, or Netflix. And so in that way, since if they are going at the speed that we want them to go, they are not sending packets. Normally, without this, they will just send faster and faster. And at some point, you'll lose packets. And it's much better if you don't. Okay, and so, and the other advantage is that we can pack this very efficiently, and you can get, well, in fact, we now have servers up to 100, even 150 gigabits per second with some newer AMD processor. So with one off-the-shelf server, you can get up to 150 gigabits per second. So that's another big advantage. Instead of having a lot of small devices doing this, you can have just one large device, much easier to manage. What can you see? For instance, this is a network where basically this is the average latency on the access side that we were measuring. And when this, they were doing this with a PPPoE, the rate limitation with a PPPoE server in their network. Now, when they switched to doing it with us, the average latency went down by a lot, from around 10 milliseconds to 4 milliseconds. That's a huge drop. Okay, and we can also do some fancy bandwidth limitation tricks, like we can have bursts, burst rates. You can have with a certain duration during which maybe it gets, so that basically subscribers may feel that they actually have a larger limit than they actually in fact have. Okay, and then finally, traffic analysis is about telling you what is going through your network. For instance, this is for 3 days of traffic in the network in Italy, where you can see maybe, for instance, 10 p.m. certain day, this was how much YouTube, Netflix, Facebook they had. You can make decisions based on this breakdown of your traffic. You can also see which are the top subscribers, the ones using your network the most every time. For instance, this is again 3 subscribers in a certain network. You can see the speeds they were reaching. So maybe you can say, oh, why is this subscriber getting always the maximum speed or not? This is information again for you to use. And finally, security. We can also, since we are there in the middle of their network, we can detect denial of service attacks, SYN floods coming out of your network, SYN floods going into your network. We can flag those subscribers that getting those attacks. We can also see the ones producing those attacks. So in that way, you can see, sometimes for instance, it's good to also even see who is producing, and maybe they have a virus or whatever in your network, because sometimes your network can get banned from certain applications if one of your subscribers is producing these denial of service attacks inadvertently. So we can tell you about that. You can see that in our application. Now, regarding the deployment, it's easy. It's a layer 2 thing. You don't need, basically, you put us in the node like a wire almost. So you have a link, goes through us, everything coming from one side goes to the other. It's like a bridge with 2 ports. Well, in fact, you can have several links going through us. Transparently, you can have an aggregate link, LACP or others going through us, and it'll be transparent. It'll be just like having 3 wires going through us. Okay, and it's just that when we limit some of those content, the speed of some of those contents, and we'll do the TCP tricks that we've showed. Then there's another port for IP with its own IP there. Yes, you have an IP address for the management to see the results, to configure. And you can also, of course, set up a bypass link. You can do that with the LACP. You can have these links so that basically if there's any failure, we can use a bypass, this bypass link, so that if the equipment goes down, then you can, or you have to do it for maintenance, the traffic will keep flowing automatically. We also have now integrated a bypass, so that basically passive bypass, so that basically that can be done without you setting up bypass link. Depends, it's an extra box that from Niagara passive bypass switch. Okay. And as for the hardware we run on, we require very little CPU power for instance, for 1 gigabit per second, even i5, even i5 or i7 CPU would be right. We use a lot of Supermicro equipment, but Dell, HP, all those servers are fine. We will work with you to see how much memory, depending on how much throughput you require. We'll tell you if what CPU you require. We have certain suggestions depending on the size of your network, on the throughput. You can also use a virtualized environment if VMware or KVM are supported. We work better with Intel network interfaces because we use DPTK, which is a library that can be very, very fast. But Intel is one of the most common choices for that in any case, and we'll tell you how much memory you require and how much, not a lot of disk. We'll either suggest you one off the shelf, or you can tell us if what you have is good enough. And we think in many cases it is, and we just send you the software, help you get it up and running, and then you can see what we tell you you can do. We have over 300 nodes in commercial service all around the net, all around the world, also in America, in South Africa, and in Europe. And now we're starting to deploy. We're getting a lot of trials now in Asia. What our customers say, basically, when they talk about how basically the complaints about the slow internet, basically in some cases just disappeared. So it also is allowing them to manage the heavy traffic situations. Also, for instance, in some of like this other customer in South Africa, they got all these improvements for very different kinds of users with different access technologies, and how they talk about how the streaming became much better. Okay, and support calls basically, for instance, about in this case a speed test, low speed test results, they basically stopped. So that's one of the best situations. That then when that happens, then of course you'll see the right away the advantages of our equipment. And also Netnam, it is in Vietnam. They also basically they did a lot of very thorough testing, and what they said is that it exceeded their expectations, and basically they are very happy with the quality and the much better quality that they have, because they are proud to be one of the highest quality ISPs in the country. So in the end, okay, we realize that we are claiming very good very nice features and very good results. So we are aware that you would like to test this before. So we offer you a free trial, a 2-week free trial, where we will help you set it up at no cost to you. You can use even a server of your own, so you don't have to even invest in hardware. Just try it out, see that you can get what we are saying you can get. And if we get what you expected from us, then only then you go ahead and try it and start and basically acquire it. And we also have a pay-as-you-grow scheme. So basically, you will pay only depending on the throughput. Okay, and you can also pay a monthly subscription, or you can get a perpetual license. We are open to all modes of. We can work in all ways. And so for the exact pricing, just contact your distributor or write to us. We have distributors all around the world, or write to us, and we will talk to you and suggest possible distributors that would be happy to help you. So here we arrived at the end, and Inigo, I don't know if there have been some questions.
Yes, Jose, thanks. We have some questions, and we'll try to go quickly, not to take a lot of time. And the first question is about if we can optimize encrypted traffic.
Yes. For us, encrypted traffic, HTTPS, TLS, goes on top of TCP. For us, it's just a bunch of bytes. We don't need to go into that. So we optimize encrypted traffic just as well as non-encrypted traffic.
Okay, thank you. Second question is if IPv6 is supported.
Yes, we support IPv6.
Okay. Third question, I think you just mentioned it, but somebody was asking how can they apply for a free trial?
Just write to us. We will ask you about your network, a few questions, so that we see which is the best place in your network to install this, and also help you with the hardware. Or if you are in one of the regions where we can supply directly the whole appliance, then we will select the one that's more suitable to you, give you the pricing, and if that everything looks okay, but you just have to first of course see it with your own eyes in your own network. Then you have these 2 weeks to do it cost-free, no commitment.
Okay. Another question is what about the metrics that are available in the system? If you can maybe explain a little bit more.
Yes, we offer you, of course, you can see the throughput that you're getting, how much traffic you have for different rate plans, for different policies, for different subscribers, and you can also see all the traffic that a certain subscriber has had over a 3-month period of time, and you can see the average speed with and without optimization. So you can see how optimization is working your network for different, for remote servers, for servers that are closer by, how the optimization works for larger downloads, for smaller downloads. And you can, of course, and then there's of course the DPI part where you can see how much traffic is flowing of different services, how much Netflix, how much YouTube, how much TikTok or you have in your network.
Okay, another question is how does BQuant compare to Presim?
Well, Presim, they do the rate plan enforcement with a focus on delays, and we also can do that. I guess, well, we can. We think they use Codel discipline for reducing delays. Okay, we think is a more advanced, because we use a single queue per application, which we believe can produce better results. And we also do TCP optimization, which they do not do. And we also do DPI and basically the ability to do application-based shaping, which I believe they don't do. So they are more focused on the delay reduction, which we can also do with a different way, which is the Codel Codel bandwidth, well, queue management, and also and they can do a lot of very nice graphics about the delay of certain sections of your network. We do more aggregated metrics, not per sector in your network and things like that.
Okay, thank you, Jose. Another question is BQuant more adapted for radio or for fiber ISPs?
We work with both because TCP is the same, of course. The thing is that, curiously, we get the best. People think that with wireless you get the best acceleration. In fact, we actually get the best with fiber, because GPON networks also have some jitter that is not very good at all for TCP. It is true that sometimes in fiber networks we accelerate a lot, but they already have a good initial speed. So going maybe from 20 to 40 megabits per second is a lot of acceleration, but maybe with 20 they were fine. So in wireless networks we do a great job, but sometimes the limit is in the radio. And now, of course, if you have a connection, a very bad connection because of the radio, maybe a Wi-Fi connection in the end was to a basement somewhere very far from the router, Wi-Fi router. If the radio cannot send, we cannot send faster than what the radio can send, so we can do magic.
Okay, another question is, can bandwidth management happen on a per access point basis in WISPs?
On per access point in WISP, right now it can't. It's not well. You can enforce different bandwidth management, different rates for different access points if you know the IP addresses of the access points of the subscribers in each access point. So, but the limit that we will enforce will be per subscriber, not per access point. However, if there is NAT happening at the access point, then we will see all the traffic coming from that access point as one IP address, and then in that case, the limit will be applied, to that IP address, which in fact will be several subscribers.
Okay, Jose, and I think that we have just one additional question. The last one is, how complex is the installation and the configuration of your system?
Well, it's in fact very easy. We all these hundreds of customers have done it. We help you all the way. The installation is very. If you do have to install, if you don't have to install it, in fact, when we send the appliance, we'll send it even with the IP address of your management port, if you like, and then that's just plug and play. And then it's about getting the right policies. We'll help you play with that. It's just setting what speed you want to different users. Or the TCP optimization requires no configuration. You just put it there and it starts working. You don't have to do anything. So and we will always it's included in all the prices our support to get it working. So it really is. You can talk to other existing users. We can put you in contact with them. It's really very straightforward.
Okay, that was the last question. So I think we can end the webinar.
Okay. Well, thank you very much. Thanks, Igor, and thanks to all the participants. And we hope we hear from you, and we will be very happy to show it to you in person with your own trial.
Thank you.
Thank you.